Okay, in the previous video we had calculated the displacement. So once the displacements are calculated, we can use the displacements to calculate the support reactions. We can also use the displacement to calculate the member forces as well. Okay, so let's move on. Okay, here we go. So if we wanted to calculate the reaction force for a horizontal, meaning that if there is a force, let's say here, if an force is being applied of 10 here, that means that a support is going to resist it with the same intensity, right? There's going to be 10. So that is how we're going to find the reaction out. So to find the reaction out, we just need to find out the force of it. Okay, all right. So first, let's calculate the force XA. Okay, we're going to use the equilibrium equations. So here for XA calculation, you can see that 500 into 1.5, 500 into 1.5, we have 700 U1 plus, similarly we have 250 U2, then minus 500 U3 plus 0, U4 plus 0, U5 plus 0, U6 minus 250 U7 minus 250 U8. And if we calculate all of these, so these are the multiplication of 500 into 1.5, 500 into 0.5, 500 into minus 1. This is the U1, U2, U3 values for the XA, Okay. Alright, so here we have the value. Once we put the values, the value of U1 is 0, the value of U2, this is 0. We know from the boundary conditions, this is 0 from boundary conditions. This is also 0 from boundary conditions. This is already 0, so we don't need to make it a 0. And then here, this is 0, 2, and right over here, this is 0, 2. So 7 and 8 are the only available values. So we have calculated U7 value. U7 value is this. This is U7 value, and this is U8 value. If you put the values right over here with minus 250 into U7 and minus 250 into U8, we'll end up with 12.78, positive 12.78 minus 3.89. So we have 8.89 K. So XA is equals to 8.89 Kips. Okay, similarly we can calculate Y2 and XB, then YB, YC, and all those things. Now similarly we can also calculate the bar force. So to calculate the bar forces, we can use this particular equation right over here. So say if a member is AB, then the equation is going to be like this. Okay, so we just need to put in the displacement values here, and EA by L we already know the value. This is SX, which is equals to 500. We already know that. So if we just place the values that we have calculated into the equations, then we're going to get the values of the forces, member forces. And this theta here is actually the bearing angle that we had calculated before. We have seen the bearing angles. Okay, so we have PAB, which is 0, PBC is coming out to be minus 11.11 K. We have PBD, and all the members are being calculated right over here. You can just look at it. Okay, similarly, if it was said that to the externally applied forces, if support C settled 0.10 feet, then U6 would have been minus 0.10 feet. So if that was known, then we can use this in the boundary conditions, and this would be the new boundary conditions, and using this we can calculate the displacements. Then we can use the displacements to calculate the support reactions, and then we can also use these displacements to calculate the member forces. Okay, so using the direct stiffness method, we can do very much of the truss analysis we could have done using the joint method or using the section method. The only hassle here is that there are lots of calculations if we use the direct stiffness method, right? But there are a smaller number of calculations if we use the joint method or the section method. But the thing is that the direct stiffness method is more accurate, as we have discussed in the first lecture. And since this is very lengthy, the solution is to use programming language. So programming language is being used to make this lengthy calculation shorter, but since this lengthy calculation is more accurate, with the help of programming language we can get more accurate analysis in lesser time. Okay, all right, so that was the assembly of stiffness matrix and load vector of a 2D truss, and using those stiffness metrics we have also seen how you can analyze a 2D truss as well. Okay, so that is it for this video. Thank you very much for watching.